Hello and welcome back to another episode of Math with Son. Today we are going to be solving systems of equations algebraically using the substitution method and the elimination method, as well as determining which method is better given a given scenario. So let's get into it. In this first problems, we have to do it with the substitution method. Now, the substitution method works out way better when you have a variable, either x or y, already isolated and by itself. So see how here the y equals is by itself, and the y equals is by itself, and over here x equals is by itself. So that means that substitution is going to be a more preferable method. So in the first scenario where they are both y equals, yes, you can substitute this in for y, but I want you guys to start recognizing that anytime you have y equals and y equals, that means that these two equations just might equal each other. So you need to set them equal to each other. Anytime you have y equals and y equals, set them equal to each other. Now from here, we're going to solve for x, so I'm going to probably add 3x over. And we get 4 is equal to 6x minus 2. Add the 2 over, you get 6 is equal to 6x, which means x is equal to 1. But you're not done. Once you get x equals, then you have to figure out what y would equal. Now you plug in the x into any of the two original equations. You can plug it into the top one or the bottom one, whatever one seems easier to you. If we plug in 1 for this x in the bottom equation, that means that y would equal 3 times 1 minus 2, which ends up being 3 times 1 is 3 minus 2 is 1. So you got your x and your y. A lot of times you can stop there, but I think it is fancier to write it in coordinate point form where you have your x and your y, x comma y. Okay? For number 2, it is also a substitution better problem because you have this part for x, that y plus 3, is what x is equal to. So you can substitute that in for this x. If we substitute it in for that x, you have 7 times all of the y plus 3 minus y would equal negative 3. Distribute the 7. We get 7y plus 21 minus y is equal to 3. Negative 3. Combine like terms, we got 7y and negative y. 7y minus y makes 6y. Plus 21 is equal to 3. Move the 21 over. If we subtract 21 from both sides, we end up with 6y is equal to negative 24. And when we divide, we get y is equal to negative 4. Again, you're not done. We got to plug that y value into either of the two equations. Top equation looks like it's way better in this case to solve for x. X equals y plus 3, so that would be negative 4 plus 3. Plugging it in for that y right there. Which means that x is equal to negative 1. Write it in coordinate form. X comma y would be negative 1 for x, negative 4 for y. Make sure you're putting it in the right order. Okay, next one for substitution, potentially the hardest one on the paper because the fractions. But other than the fractions, this is not that bad. We know that y equals the negative 3 over 2x minus 5. We can plug that in for this y right here. And if we do that, if we substitute all of this in for that y right there, that means that we get negative 3 over 2x minus 5. That's plugging in for this y. Minus 3 equals 2 over 3 times x plus 1. You have a lot of options for what to do here. You could distribute the 2 over 3. You could combine like terms. You could attempt to get rid of the fraction, which is what I'm going to do. Before I do that, I'm going to combine the negative 5 and the negative 3 to make negative 8 because I got the power to do that. So that's negative 8. A little sloppy, but it's okay. After you do that, we have to get rid of these fractions or distribute the fractions. So I would rather get rid of the fractions. I'm going to start by multiplying everything by 3. I don't like this 3 right here. So if I multiply everything by 3, if I do that, it cancels all the 3's out. So it would be negative 3 over 2x times 3 minus 8 times 3 equals 2 over 3 times x plus 1 times 3. Now here, the 3's cancel. That's the whole idea of multiplying by the 3. We have 3 times 3 on the top here makes negative 9 over 2x minus 24 equals 2 times x plus 1. Now in this scenario, you could multiply everything by 2 to get rid of that. You could also just distribute this 2 to kind of deal with that. So let's do that. Let's not. I know what 9 divided by 2 is. That's negative 4.5. That's not the worst case in the world. Minus 24 is equal to 2x plus 2. Then we're going to subtract the 2x over. You get negative 6.5x. And I'm going to add the 24 to the other side. That equals 26. So 26 divided by 6.5, that is probably a calculator problem, which I'm going to grab real quick. Woo! It's across the table. 26, it's validating. 26 divided by 6.5 is equal to 4. So this is going to be a negative 4 because it was a negative 6.5. So that's the x value. What would the y value be? Well, you got two options to plug it in. I recommend the top one. So the top equation, the y value, we plug in the x value would be negative 3 over 2 times negative 4 minus 5. 3 times 4 makes 12 over 2 minus 5. 12 divided by 2 is 6. Minus 5 makes 1. And because it was a negative 3 over 2 and that was a negative 4, then we end up with a positive 1. So we got a positive 1 value for y, writing it in x comma y formula, negative 4 comma 1. All right, so that's the substitution method. Elimination method is my probably favorite method. It is going to work out way, way better and quicker for that matter if all of the things are lined up. See how the x's are lined up, the y's are lined up, the numbers are lined up? X is lined up, Y is lined up, numbers lined up. Even the equal signs kind of need to be lined up. So if that's the case, if you can add straight down and cause things to eliminate, meaning cancel out, then you're in business. So here, look at how the 4y and negative 4y, when we add straight down, they cancel out. So that goes away. And you're left with negative 3x is equal to 24. Which means that x would equal negative 8 when we solve. Look at how quick that was. Now we get to plug in the negative 8. We're still not done. Into the x or the y in the top or the bottom equation. Should be the x in this case. So I'm going to plug it into the bottom equation. We got 4 times negative 8 minus 4y equals 0. We end up with negative 32 minus 4y equals 0. Which means negative 4y would equal positive 32 when we add that 32 over, which means y would equal negative 8 as well. Convenient, I guess. I don't know. Negative 8 comma negative 8 would be your x comma y solution to the problem. Next one, we got 4x plus 2y equals 10, and x minus y is equal to 13. You have two options for how to eliminate. In order to eliminate, you need to have the same value for the y's or the x's, and they need to be opposite signs. So this 2y and that negative y are already opposite signs, so I'm going to choose to eliminate the x's. I could choose to eliminate I'm going to choose to eliminate the y's. I could choose to eliminate the x's by multiplying by negative 4. But in this case, I think it would be quicker to multiply this bottom equation by 2 because 2 times negative 2 would cancel. So if we did that, the top equation I haven't done anything for, so I'm just rewriting. If I distribute that 2, we get 2x minus 2y is equal to 26. And now when we add straight down, it would eliminate. We get 6x is equal to 36, which means x is equal to 6. Plugging that x into either of the two equations, I again am going to choose to plug it into the bottom equation. 6 is what x is, minus y is equal to 13. Move the 6 over, negative y would equal 13 minus 6 would be positive 7, which means regular y is equal to negative 7. Write it as a coordinate point. There's our solution. 6 comma negative 7. Number 3, we got 2y minus 3x equals 10. We got 5y minus 5x equals 15. So in this case, we have a scenario where we can't just multiply the x or the top or the bottom equation. We have to multiply both, all right? And I am going to choose to eliminate, I don't know, the y's, I guess. So if I did that, in this case, I'm going to multiply this top equation by -5, and I'm going to choose to multiply the bottom equation by +2. By doing that, 5 times 2 is -10. 5 times 2 is +10. That would eliminate. So I'm going to distribute. I'm going to get -10y, and then I'm going to get 5 times -3 is +15x. 5 times 10 is -50. 2 times 5 is +10y. 2 times that is -10x. And then 2 times 15 is 30. Add straight down. The y's go away. 15x and 10x makes the +5x. 50 and 30 makes -20, which means x is equal to -4. Plug it into any of the equations you want once you get one variable. I'm going to plug it into the top equation this time. 2y minus 3 times, plugging in the x into the top equation, -4, is equal to 10. 2y plus 12 equals 10. 2y, subtract the 12, -2, y would equal -1. Write your answer as a coordinate point, -4, -1, and call it a day. Okay, so those are the two main methods, but what do you do when you're not told what method to use? You have to choose which method you would prefer. So on this equation right here, given this solution or this scenario, I would choose to use the substitution method. Why? Because you already know what y is equal to. So you could substitute that in for y. If we do that, we get 2x minus, don't forget to distribute the negative. That is a big mistake that a lot of people make. Distribute the negative. 2x minus 3x minus 1 is equal to -3. So these three problems right here are either unique scenarios or problems that you might be making a mistake for, in addition to having to choose which method to use. 2x minus 3x is equal to -1x minus 1 equals -3. -1x equals -2. X would equal not 1, 2. Plugging that x back in, we get y would equal 3 times 2 plus 1, which means that y would equal 7. You got your point at 2, 7 for your solution. All right. What about this one over here? They're all lined up, but they're kind of, we got a bunch of things to deal with here. You got the 10 that you could add over. You got the 30 that you could add over. You do not have to. And not only that, but I also am going to choose to use elimination. You already kind of tell because they're all lined up. Even though we have an additional term, so to speak, they're all lined up. I am going to choose to eliminate the x's. If I wanted to get the x's to go away, this 2x would need to be a -6x to be able to eliminate with the +6x. So I'm going to have to multiply by -3. And if I do that, I'm going to rewrite that equation right underneath here. I'm going to distribute everything. We got 2 times 3, which is -6x. We got 3 times y, which is -3y. We got 3 times that, which is +30, is equal to 0, because 3 times 0 is 0. Now I'm adding these two. 6x and -6x cancels. Okay, that's what we expected. 3y and -3y cancels. Also what we expect. No, we didn't expect that. That's okay. 30 and -30, they cancel. You get 0 equals 0. Well, what would x be then if 0 is equal to 0? And the answer to that is you have a scenario here. If you get 0 equals 0, that is infinite solutions. If you have 0 equals any number other than 0, that would be no solutions. All right, so 0 equals 0, infinite. 0 equals a number, no solution. Last and final problem of the afternoon or morning, depending on what time you're watching this, is right here. We have a point slope form and an already graphed form. Now, the fact that it's already graphed indicates to me that maybe I should use the graph. And if the graph doesn't work, then I'm going to have to use elimination or substitution. So here we have our point, change the sign, 3, change the sign, 2, right by 1, 2, 3, up by 1, 2. And my slope is 3. So I need to go up by 1, 2, 3, and over by 1. If, and only if, it crosses through perfectly, will I be able to use this solution. And it looks like it does, which means that my solution is 4 and comma 5. So 4 comma 5 would be the solution in this case, would be my solution. And that is going to do it for this one, everybody. Until next time, I will see y'all later. Stay positive, my friends. Bye.